the number is 74. We need to know the various divisibility rules. Okay, we start with 1. 1 divides 74. 174s are 74. So 1 and 74 automatically they become factors. After 1 you go for 2, and 74 is divisible by 2. Okay, when you divide 74 with 2, you get 37 as the quotient. So both the divisor and quotient, they become the factors of the dividend, that is 74, the given number. Then 74 is not divisible by all these numbers 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you want to know the divisibility rules for 3, 4, 5, 6 up to 12, you will have to go through my session on the divisibility rules. So the final list of factors will be 1, 2, 37 and 74. We need to find the factors for 348. So as usual, we start with 1, and 1 divides 348. 1 348s are 348. So both 1 and 348, they become the factors for 348. Then you select 2. 2 divides 348. The quotient is 174. So 2 and 174 become factors. Now in between 174 and 348, there is no number that can divide 348 evenly by giving a remainder 0. So you don't have to check whether 348 is divisible by any number in between 174 and 348. Okay, because we don't have factors in between 1 and 2. If there is a number that divides 348, if there is a number in between 174 and 348 that divides 348, then there must be a number in between 1 and 2. Okay, that is the logic. Now we select 3. 3 divides 348 because the sum of digits in the number 348, it is divisible by 3. So 348 is divisible by 3. So 3 and 116 are factors because 3 into 116 equal to 348. Now 348 is divisible by 4. So 4 and 87 become factors because 4 87s are 348. Then 348 is divisible by 6. Because it is both divisible by 2 and 3, the number is divisible by 6 also. So 6 and 58 are factors. 348 is divisible by 12 because if a number is divisible by 3 and 4, then it is automatically divisible by 12. Okay, so 12 and 29, they become factors. Now there is no number in between 12 and 29 that can divide 348. Okay, so the list of factors will be like this: 1, 2, 3, 4, 6, 12, 29, 58, 87, 116 and 174. Now you will have to find the prime factors for 2794. I have demonstrated 2 different techniques in the previous session. So the first technique, you use repeated division. You select the prime numbers as the divisors starting with 2. So the number is divisible by 2. 1397 is 2794. Okay, here the remainder is 0. 2 evenly divides this number. So 2 into 1397 will be 2794. Then there is no prime number in between 2 and 11 that can divide 1397. How can you come to that conclusion? By using divisibility rules. So this is somewhat a time consuming process because you have to check, because the prime numbers in between 2 and 11 are 3, 5, 7. So 3, 5, 7, they do not divide 2794 evenly. So the prime number after 7 is 11, and 11 divides this number, because in 1397 what are the digits in alternative places? 1 and 9, 3 and 7. 1 plus 9 is 10, 3 plus 7 is 10, 10 minus 10 is 0, and 11 zeros are 0. So in that way you can come to the conclusion 11 divides this number, because the difference between the sum of digits in the alternative positions must be either 0 or a number divisible by 11. Okay, so here I have 127. There is no number that divides 127. 127 itself is a prime number. So 2794, how can you represent it as a product of prime factors? It will be 2 into 11 into 127. This is another technique. By using the factorization tree, you can find the prime factors. So here also, this is the 2794. You start with 2. 2 1397s are 2794. Then again 11 divides this number 127 times. So this is the representation. So the prime factors for 2794 are 2, 11 and 127. Now this is a big number, 14,672. You have to find the prime factors. You can use the repeated division method or the factorization tree method. So here you always start with the first prime number, that is 2. Until you get a number which is not divisible by 2, then you select 3. So here 2 7s 14, 2 3s are 6, 2 3s are 6, 1 is remainder. You will have 12, 2 6s are 12. Then you have 2 here. 2 3s are 6. There is 1 3. 2 6s are 12. There is again 1 3. 2 6s are 12. There is 1 6. 2 8s are 16. 0 is the remainder. Then this 3668 is divisible by 2 because it ends with 8, which is an even number. So this whole number is divisible by 2. 2 1s are 2. 2 8s are 16. 2 3s are 6. 2 4s are 8. 0 remainder. Then this is again an even number. It is divisible by 2. 2 9s are 18. Okay, 2 1s are 2, and you have 1 remaining. 1 4, 2 7s are 14. Then this number is not divisible by 3 and 5, but it is divisible by 7. So 7 1s are 7, 21 is remaining. So 7 3s are 21 and 7 1s are 7. And finally you get 131, which is a prime number. Okay, and you represent as the product of prime factors 2 into 2 into 2 into 2 into 7 into 131. Here dot represents the multiplication operator. Okay, the arithmetic operator, multiplication. So 2 power 4 into 7 into 131. Again in factorization tree you do the same operation. 2 7 3 3 6 are 14,672. Then 2 3,668 times will be 7336. Then again 2, again 2. Here 3 and 5 do not divide 9 17, so you go for 7. 7 131s are 917. So this is the end of the session. Thank you.